Derive the expression for gain and input resistance for voltage shunt feedback amplifier. Draw the block diagram of shunt feedback amplifier and derive the expression for gain, input resistance and output resistance. Okay, so when you see the first question and the second question is ultimately same, right? What's the reason? So first question, it is voltage shunt feedback. The other name for voltage shunt feedback is shunt feedback. So both the questions are same. Okay, so in the case of voltage shunt feedback, the first parameter signifies the output parameter and the second parameter indicates the input. So output is your voltage. Okay, output is your voltage. And what is your input? If it is input is the shunt connection, your input is current. Okay, input is current. Similarly here, shunt feedback means the first parameter represents your input and the second parameter represents your output. If the input is a shunt connection, you know that it is current, and if the output is a shunt connection, it is voltage. Okay, so ultimately both the questions are signifying the same feedback amplifier. Okay, so let us start with drawing the block diagram of your voltage shunt feedback or shunt feedback amplifier. So what is your gain? Gain, open loop gain A is equal to your output divided by input. So what is your output? Output is your voltage and input is your current, right? II. And the second parameter is your feedback network. Feedback network, so you will be having the input. Input is your current, right? Input is your current. So let me take it as IS. Both are shunt connection. And your output is your voltage. Output is your voltage. So both you have your shunt connection. A portion of the output will be fed back as the input. Okay. Here also you will be having shunt connection. Okay, so what will be your beta? Now a portion of the output will be fed back as the input. So now the feedback network, the input will be your voltage, and what will be the output? Output will be your current IF. So what will be your IF? IF will be equal to, so this is your flowing away, and what is this current? It is equal to II. So what will be your IF? IF will be equal to beta into V naught. Beta into V naught. So let me write the equations once again. A is equal to, amplifier gain is equal to V naught divided by II. Then IF is equal to beta into V naught. What is your beta? Feedback gain is equal to, beta is equal to IF divided by V naught. So these are some of the formulas which you can write from the circuit. And what about your current? If I apply the current KCL across this, you know that I is flowing away, IF is also flowing away, IS is flowing towards your circuit. So what will be your equation? IS minus, it is flowing away, right? Minus II minus IF is equal to 0. So you can take IS is equal to II plus IF. Okay. So this will be your next important equation. Fine. So let me redraw this diagram uh, by its equivalent circuit. I am going to replace the amplifier by its own equivalent circuit. So what will be your equivalent circuit? Input is going to be your current IS, right? And it is going to, input side of the amplifier will be replaced by your input resistance Ri, okay? And your output side will be replaced by your voltage source, that is, what is your voltage source? A into II. So what is your output voltage? V naught is equal to A into II. So same thing I have written it here. So since the output is your voltage, you have to replace it by a Thevenin's equivalent circuit. So I am taking the output resistance as R naught. Okay. So this will be your transistor equivalent circuit. Since output is voltage, I am repeating it once again. Since the output is voltage, you are going to replace it by a Thevenin's equivalent circuit. Voltage source and your resistance R naught. Okay, and you have here your load resistance RL. Now here you have the shunt connection. Remaining things are going to be the same. So here you have a shunt connection. It will go to your beta, that is your feedback network beta. Now beta will be equal to IF divided by V naught. right? So here also you will be having the shunt connection. So what will be your IF? IF will be equal to beta into V naught. So IF is flowing away and your input current to your amplifier is II. Okay, fine. So now let us go for our derivation. First we'll derive the gain, then we'll go for input resistance, and later we'll go for output resistance. So case 1 or A part, we are going to find out your gain. Okay, so what will be your gain? So let us consider, you know that the open loop gain A is equal to V naught divided by II, right? Open loop gain A is equal to V naught divided by II. Now you have to find out what is your closed loop gain. So what will be your closed loop gain? That is with feedback. Output remains the same, but it is that is your current will be replaced by your overall source current. So it is equal to Is. Okay. So AF will be equal to V naught divided by Is. Now what will be your, can we replace what is your V naught? You know that V naught is equal to, from here you know that V naught is equal to A into II, right? A into II. Okay, so just I am going to replace this V naught. So V naught will be equal to A into II divided by Is. Now we have already found out what is your Is, right? Next you are going to substitute the value for Is. So AF will be equal to A into II divided by what is your Is? II plus IF, right? II plus IF. Now you know that instead of IF, can we substitute the value? What is your IF? IF will be equal to beta into V naught. So AF will be equal to A into II divided by II plus what is your IF in terms of beta and V naught, which is equal to beta into V naught. Now what is your again you have to you have a parameter V naught. You have to replace your V naught. What will be your V naught? You can replace it by again into A into II. So A into II divided by II plus beta into V naught is replaced by A into IA. So can we take II as common and cancel everything? So cancel II. So you'll be getting AF will be equal to A divided by 1 plus A beta. Okay, this is the relationship between your closed loop gain and your open loop gain. AF is equal to A divided by 1 plus A beta. So first parameter is found out, gain. So now we'll go for the second parameter to find out the input resistance. So the B part which you are going to find out is your input resistance. So in order to find out the input resistance, let me draw quickly the circuit, equivalent circuit once again. Across the input side, you will be having your current Is, right? And I am going to replace your amplifier by means of its equivalent circuit, input resistance Ri. The output side will be converted to your voltage source, that is A into IA, Thevenin's equivalent circuit, and output resistance R1, load resistance RL, right? RL. So this is going to be your transistor. Okay, and here you will be having the shunt connection. Beta is equal to IF divided by V naught. So the same signal will be going it as the feedback network. Here also you will be having the shunt connection. So the feedback current is equal to IF and the current flowing towards the amplifier is equal to II. Okay, so you are going to find out the input resistance. So what is your input resistance with feedback? Let me consider the input resistance with feedback is represented by RIF. RIF is equal to input voltage divided by the overall input current. So it is equal to IS. So now you can substitute the value for IS. You know what is IS in the previous derivation you have done. VI divided by II plus IF, right? Now, can you substitute what is your IF? IF is equal to, you know that, which is equal to beta into V naught. So, R IF is equal to VI divided by II plus beta into V naught. Now, again, can you substitute the value for V naught? What do you know? You know that V naught is equal to A into II, right? A into II. So, R IF will be equal to VI divided by II plus beta into A into II. So if you divide by II in both numerator and denominator, what you will be getting, RIF is equal to VI divided by II divided by II divided by II plus beta into AII divided by II. So what you will be getting? So I can write that RIF is equal to VI divided by II. I can replace it by RI divided by, so II will get cancelled, right? So here you will be getting 1 plus A into beta. So now you have found out the input resistance with feedback is equal to input resistance without feedback divided by 1 plus A beta. So you know that both is a shunt connection, right? So what will be the clue is that since both is a shunt connection, your input resistance and output resistance will decrease. So here Ri divided by 1 plus beta A beta, it is decreasing. The C part, you are going to find out the output resistance. Okay, so in order to find out the output resistance, what is the condition you have to do? You have to make Is is equal to 0. Okay, so you are going to make Is is equal to 0. So Is will be open now. Okay, the next assumption what you are going to make is the output, you are going to assume the output voltage is equal to capital V and the output current is equal to capital I. So I am going to replace here the output voltage. Let me take it as output voltage is equal to capital V. Okay, and the output current is equal to capital I. Okay, I am assuming. So output voltage is equal to V and the output current is equal to capital I. Okay, so now Is is equal to 0, right? So you know that Is is equal to II plus If. If Is is equal to 0, then you can write that II is equal to minus If. Correct? Or IF is equal to minus II. Okay, so you know that what is your IF? IF is equal to beta into V naught. Here also it will be equal to not V naught. I am going to assume it as capital V. Same voltage, output voltage is fed back as input. So I can replace and write that II is equal to, instead of IF, you are going to substitute the value for beta into V. Okay, so this will be my first equation. II is equal to minus beta into V. Now if I apply the loop equation, output loop, KVL across the output loop, what you will be getting? So here you will be having plus to minus, so you will be having the voltage V, here you have the resistance R0 and your current is equal to I. So here it is plus to minus, here it is plus to minus, right? So what will be your drop here? So minus R0 into I, then here it is plus to minus. So minus A into II is equal to 0. Okay. So V minus R0 into I minus A into II is equal to 0. Now can you substitute what is your II? Already you have you know the value for II. So V minus R0 into I minus A into, instead of II, you are going to substitute minus beta into V. So minus into minus, you will be getting plus. Plus beta into V is equal to 0. Can you take capital V as common? So V, you will be getting 1 plus A into beta minus R0 into I. Okay, is equal to 0. So take it towards the R0 into I towards the opposite side. So you will be getting V into 1 plus A beta is equal to R0 into I. Okay. But you know that what is your output resistance? R0 F. R0 F will be equal to capital V output voltage divided by your output current. So if you configure this equation, I am going to retain V as such. In the left hand side, I am going to bring this I towards down. So V by I will be equal to capital R naught divided by 1 plus A beta will come towards opposite side. So 1 plus A beta. So you know that V by I is equal to output resistance with feedback. So R naught of is equal to R naught divided by 1 plus A beta. If you can observe both the equation, input resistance with feedback and output resistance with feedback, both are decreasing in nature since it is a shunt connection. Okay, so these are the different equations you have to write for the questions.